These are the frequently asked questions for Algebra 2, and this would be for section 5.8, day 2. We are looking at some regression problems here. It says the table shows the United States gross domestic product for selected years. Construct curves using cubic regression and quartic regression to model the data. Which curve seems most likely to model gross domestic product over the years? And so one of the first things that I thought I was going to do is I'm going to go ahead and use 60, 70, 80, 90, and 100 here, and my x values will actually be years since 1900 when I do that. So what I need to do is get this information into the calculator because they want cubic regression and quartic regression for those models. So I put the information in underneath stats, edit. So it's already in there and ready to go for both of our cubic and quartic regressions. So we'll hit stats and calculate, and we'll do the cubic regression first, number 6. And I do have my information in list 1 and list 2. And for this problem, there's no need for me to store it under y equals. We certainly could just to remind everybody how to do that, so I'll do that. We'll hit the variables button and then arrow to the right once for y variables, number 1 for functions, and then number 1 for y sub 1, and then down to calculate and let it go. So there is our model for the cubic regression, and we would write down, well, we probably wouldn't go much farther than hundredths. I mean, we've got a lot of numbers there. I know the book wrote the entire thing down, but you might not want to do that. You might just want to take hundredths, thousandths, something along those lines when you're thinking about that cubic. So our cubic would be y equals negative 0.0. Well, if we round 19 up, that'll be 20. And that's x cubed plus 10.676 x squared minus 1086.250x plus 31,565.157. So there's our cubic regression model. And I thought, just for the sake of being able to see it, they did ask us which of these curves most likely models gross domestic product. But let's look at that r value first before I leave this window. We have an r squared value of 0.99998. So that is awfully close to 1, awfully close. So it might not be a bad model. But if we go to window, we had values in there up to 100, so maybe I will go from 0 to 200 to see what the graph looks like. And I made my y window from 0 to 100,000, hoping to be able to see that curve. And so we can see what's going on with that cubic in the first quadrant, which would be real life because we want to have positive values. So there's the cubic, and what that's telling us is while GDP may go down for a while, and that's what we saw in the table, it is going to go back up. And then after that, if things are good, if the economy stays good, it'll just keep going up. And that's what that model tells us. So now the second part of this was that we want to go back and look at a quartic regression. So same data. So we're not going to have to go back into stats edit. We can just go straight to stats calculate, and stats calculate. We now want quartic regression, which is down here as number 7. And I do still have that information in list 1 and list 2, but this time I'll do variables, y variables for functions, the second, y sub 2 down there, and calculate so I can see both of those graphs at one time if I want to take a look at those. And so I get that little monster for my quartic, and that is the part that we would need to write down for our quartic. So y equals negative 0.001 x to the 4th plus 0.361 x to the 3rd minus 34.556 x squared plus 1269.845, and that would be x to the first. And then we have minus 13892.5. So those would be the two models, the cubic and the quartic. And now it says, we keep reading, and it says which curve most likely would we use? You know, which one would we think is going to be the best fit? And I look at my quartic, and up in the screen there, I see that r squared actually came out to a perfect 1 for the quartic model. Well, let's graph it. So far, mathematically, we would pick the quartic. That one is a perfect fit for regression. So again, it's graphing that cubic first. We're going to see that. And then in red, we will see that quartic come up. So notice that quartic starting a little lower. And as you look at that quartic, you start to think, you know what, that might make more sense that there are little ups and downs in the GDP, and it doesn't shoot off forever anyway. So the quartic would be the better model, and our reasoning would be because r squared equals 1. So the quartic is the best model because r squared equals 1. If we take the square root of both sides there, we'll get r equals 1, which is a perfect fit. And that would be the reason that we would want to use that one, use that model for the quartic. The next one is number 35, and we've got a table below that's showing the percentage of the U.S. labor force in unions for selected years between 1955 and 2005. So again, instead of punching in the 19s, I would just do x equals years since 1900. And that'll take a little bit of the punching out of the way here. But we need to get that data in. So I'm going to stop the video for a second so that I can type in this data. Data in for this, and this is the year and then percentage of that U.S. labor force. And it said make a scatter plot of the data. So we're just going to make a sketch of whatever we see on the calculator. I'm going to put these numbers in. And under stats, calculate, stats edit, to give you a peek and see that I have all of that data in there. Now we want to go ahead and graph this, but we need to turn the stat plots on. So second y equals number 1. And while the cursor is over the top of on, we press enter. And then I notice it is set to a scatter plot from list 1 and list 2, and it does have the markings that I need. But this is going to be about the window, because this data is not negative 10 to 10 material. We had 55 to 105 as the numbers that we put in. So maybe I'll do 50 to 110. And then the y was all about percentages. And percentages, of course, are from 0 to 100. But we certainly didn't see 100 in any of those numbers we had up there. So maybe 0 to 50%. And graph. And so that would be what I need to see on your paper, is just some dots representing what went on here. And you don't even have to really make sure that you have all the dots on there or have exactly the pattern that you see up there. I just want to know what you saw when you were able to get that. And it says what kind of polynomial model seems to be most appropriate. Well, if we see that scatter plot, that almost looks like a line for 35. I mean, if we just connected those up, there would be very few that we are not able to get in there. So we could say a line, or we could say, well, it does look like it has a little bit of a curve to it. So maybe with that little bump in there, maybe this is going to be part of a cubic. So when it says make a scatter plot of the data, what kind of polynomial model seems to be most appropriate, they're asking us what we want to try. you know? And since this has so many points on it, and it isn't exactly a line, I think I'm going to go with a cubic and give that a try. So for A, once I see the points, I'm going to try a cubic. And then it says use a graphing calculator to find that type of model from A. So stats, arrow to the right once for calculate, and I wanted number 6, a cubic. And I saw there are some follow-up questions. So once I get down to store regression equation, I'm going to put variables, y variables, number 1, and number 1, and just store all of that in y sub 1 just in case I need it later. And again, you're going to see that the book answer is going to have all of that regression equation in there, and I don't think I would write all of that in there. So for B, with a cubic, we have y equals, and we see that we've got 2.2688423 times 10 to the negative 4th. So that is 0.1230, and maybe I'll just put 27 down there. X to the 3rd minus 0.05255 x squared plus 3.5053 x minus 38.6457. You know, just doing some rounding on the end there for that last piece. Now our r squared value is 0.99. So if we take the square root of both sides, it's probably going to round to 1. So not a bad model. It's not a perfect fit either. So for C, it says use the model you found in part B to predict the percent of the labor force in the unions in the year 2020. Well, remember, I said that my X was going to be the year since 1900, so that's been 120 years later. And that's the reason that I went ahead and put that in as y sub 1, is so that I can use the table to figure that out for 120. So I'm going to hit second window, because that's table set, and I'm going to start that at 120. And then second graph. And the first one that we see up there is that 120 years later. So 17.253% is what my model would predict for 2020. And then for D, it says, do I have much confidence in this prediction, and explain? Well, I don't, for this reason. There's not enough data up there to give me a good look at whether or not this is a cubic or whether or not it's a straight line. I'm just not seeing everything that I would like to see to be 100% sure, and that's another part of the reason right there, because R is not 1. So for D, easiest thing to explain would be I do not have a lot of confidence in this model. Because R will not be equal to 1. That would be the easiest way to explain it. But like I said, I would like to see more of the data. I mean, they skipped around every 5 years. Maybe if we saw all of this data from 1955 to 2005, I might feel a little more comfortable making predictions with it. But right now, this just isn't enough information. And that will be all.